By means of this video, I'm going to go through the exercise that was provided to the trainers at the Burns Workshop this fall. And we start out here in the folder that contains the basic files. We have the 2024 data entry module for the Indian Jack Meadow, but also the 2011 and 2021 data. Also, we have the data analysis module and statistical analysis module and the instructions for the exercise. So let's look at those instructions. MIM data was collected on all 10 indicators at the Indian Jack Meadow, 2011, 2021, 2024. So it contains both the short-term and the long-term indicators. The 2011 and 21 have been uploaded and corrected in the most recent data analysis module. The 2024 data are contained in the most recent data entry module. Now, one thing I've done in this particular explanation, we've been doing some work on the data analysis module, and there's now a 2025 version. So I've actually uploaded the 2011 and all three of them, 2021 and the 24 data, into this most recent module, and that's what I'll be using in this presentation. So the tasks are upload the 2024 data from the entry module into the data analysis module. You have the 24 version. I actually am going to go through and do that in the 25 version. This will give you an idea of some of the new features that are available there. Then run the correction macros to correct the data and add the satellite image and the photos taken in 24 to that file. And any comparison photos with the 2021 and 2011 modules as desired. I've got a comparison that will be of interest to you. Generate the plant list by running the generate plant list macro, and then run the bootstrap and spatial macros. If any indicators show spatially autocorrelated on the data summary sheet, examine the spatial tab to see if there's a subsample that can be used to provide a corrected 95% confidence interval. This SAC has been removed in the 95 version, and we now have the system actually produce for you the scenario that avoids spatial autocorrelation. In other words, what part of the DMAs are we able to use every other sample point, a broader spacing between samples? Are we getting no spatial autocorrelation on either side of the stream, just the left bank or just the right bank? Or if worse comes to worse, every third sample that are much more widely spaced apart. Anyway, the current version of the module will allow you will actually look at those and select the scenario that has the largest number of samples. Appendix D then has been updated in the data instructions guide, and it will explain that. You are using the old Appendix D, which is having you manually determine which subsample to use. Anyway, then once we've got all the data entered into and corrected in the three modules, we open the statistical analysis module and run the get data macros for all 3 years, and then follow the instructions on the comp tab to produce trend graphs for the 3 years with those graphs showing a change, and if the trend graphs indicate a statistically significant change, and then write a report based on your findings. So we'll go through all of these steps in this video presentation. So step number 1, we're going to open the data analysis module and upload the Indian Jack Meadow for this 2024 year. One thing we do when we start out, you notice that there's some links up here at the very beginning. If you're uploading historical data, or if you're uploading just data from the livestock use module, the short-term indicators, click on those links. They take you to steps that you should follow. And actually, we're going to go down and look at the steps for just uploading this data entry module for 2024, suggested steps. So open the workbook, select Files, Save As, and migrate to your choice, and then name the file. So that's what we're going to do. We're going to save this file right now to the Indian Jack folder. So So I want to do the same format that I had for the 21. This is going to be the 24. So data analysis module aired for Indian Jack in 2024. That's what this is going to be. That's the first thing you do is save it. And then the next step is use the macro get data to import data from the data entry file. And we're going to just follow these steps right on down as I go through here. So get data, and we're going to get data from our Indian Jack Meadow data entry module right there. Open that up. Okay. The data have now been uploaded. The next step is to go through the data correction macros, one at a time. We got to correct the plant codes. We go in here and we find that Ardor is not in the system. Well, that seems kind of strange. Ardor should be in the system. Probably what it is there's a value, that's a number on it, and that's the case, Ardor 2. Okay, we'll put Ardor 2 in. Row is not. That's probably Rosa Woodsii, row woe. So hit an R on the list here, go down to row woe, right there. Okay, and it'll replace everywhere that occurrence occurred with row woe. EQUIS is probably equisetum. We want equis, QUIS, so hit the E, go down, equis, there it is, right there. Replace it. Carex rhizome. Actually, in the system, the code is Carex RH. So we'll go down to Carex RH right here and replace that with Carex RH. Juar, Juncus articus, hit a J. That has a 2 behind it. Articus does. Juar 2 right there. Okay. And Migu. Now, Mimulus, we have some Mimulus in the system, but Migu is not in there. Okay, what do? We quit. Okay, I'll go out. And we go to the Plants tab. Now, I want to draw your attention to the fact that there are other plants over here, additional, less common riparian plants. Let's see if Migu is in there. Ah, there it is right there. Mimulus guitatus, monkey flower. Okay, we're going to pull that, copy it, and we're going to bring it over into the plants tab, right to the bottom here. And when we paste values right there. Okay, now we won't pick up Migu anymore because we've now pasted it into the plant list. Now the plant code 0 is not in the system. Of course not. 0 is not a plant. So we're going to quit this one, and we're here in the data sheet. Where is there a 0 in our plant codes? All right, here somebody put a 0 in here for these. I'm going to just delete those. Here's one here too, and one there, and one there, and one there. Is there more in here? There's no more zeros, but I did see right here a 1. We don't want to have a 1 in the species code for woody riparian. Okay. Now we've made some changes, so I'm going to go ahead and hit the save button just to update it. And we'll go back to correcting plant codes. Let's see if there's anything else to correct in here. Plant code Carex rhizome. So we got another incidence of Carex rhizomatus in here that cropped up. Carex RH is the right code. So we're going on down, and we've come to the end. Good. So we've taken care of the plant codes. Save. Now, next correction is check for errors with red circles. We'll start with the header. form. Oh, red circle right here. This was not written in. GR, gravel, that's the substrate type. Don't see anything else to put in right here. Photo DMA. Are there any red circles here on the DMA sheet? Looks like why is Equus circled? Well, Equus is a form. We don't want to have a form for a stubble height, so we'll delete that. Okay. Let's go to our substrate form. Any red circles? Nope. And the Thalweg form? Nope. So we're good for those errors. Now let's do the plant. Let's look at the plant composition. This table right here on the left-hand side, right here is the plant composition table. And we go down and look for red circles on it. Here's one right here. So that's a 90. There's these two 5s. So they're probably 10s to make that 100. Okay, that's the only one I found. Now, before we send this back, we need to look and check, see if our plot numbers are continuous. And if the value above is no, NO, then click the numbers, then check the number sequence. Now, this is new to the 2025 version of the module. It helps us. So somewhere in our data, there's an out of sequence. There it is right there. So we got a 46 right here. And now, notice that there 46 will be duplicated. We've got to do a 47, 48, 49, so on. I'm going to continue, and then we'll come back. Okay, now I've corrected the plot numbers, made sure that they're continuous, and now we have a yes, which tells us that they're good. Once we've done all that, do not forget to send the corrected data back to the DMA sheet. Okay, that's our plant composition. Now, when you, this one here also is critical. When you hit the plant composition correction macro, it's going to create a table that's used elsewhere in the module. So that one's an important. Make sure you always do that one regardless of anything else you do in this module. Woody plant heights, it's always good to come through and look at those. Again, red circles mean something. Here we've got Ardor, and it's 50-50 with SAX and plot 10. We don't really know the height, but usually Ardor's pretty short, so we'll put a 2 in for it. Then we have ROO. Sometimes people don't put heights in because they think that it's only riparian woody species, but no, all woody species go into plant height. It's just in age class that we want to have riparian species, and of course in woody use it's the key woody species which are also riparian most of the time. Sometimes people designate ROO as a key species because it's palatable in their area. This one here is an understory plant, so it's a 1. This ROO here is also an understory, so is this one. And that looks like it's all. There's not much woody at the Indian Jack Meadow. Okay, so that's sent back. Woody plant composition. The next step after doing the correction macros is to generate the plant list. So we hit the generate plant list macro, watch it blink for a while. Then we've got a list of plants here with their relative composition, cover, and constancy. And this now generates the stubble height values, and the woody heights, woody uses, etc. It's important also to always generate the plant list. Now, the steps, they tell us in the steps that the final 2 steps are to run the 2 data analysis macros. So we run the bootstrap analysis, which is done on the short-term indicators. Notice that we got some division by zeros, so it defaulted to the smaller values. We couldn't get a bootstrap on woodies because there were so few in the sample. And the spatial analysis then is done. This one will run for a while. This is analyzing our plot data, plot by plot, to see if there's correlations between plots. It uses a standard Pearson correlation coefficient, similar to what is done to analyze autocorrelation with time series data. But here we're, of course, looking at it in terms of spatial data along a transect, the green line transect. It comes to a table of compilation, and this compiles the data from this spatial analysis. For ecological status, for example, it gives us what the metric value and the 95% confidence interval is, and the number of sample points for both banks, adjacent sample points, both banks every other sample point, both banks every third sample point, left bank adjacent, left bank every other, right bank adjacent, right bank every other, so on and so forth. These are the data that are used down here, and then down here are the tests. These are the final results of the spatial autocorrelation tests. If the significance of the correlation is yes, then we're saying it is autocorrelated. But if no, then it will generate values here. And then the value associated with the highest n, not autocorrelated, is presented in red at the bottom. And this is the value that goes over to the data summary table. Now, we provided a table to the right here that would shows you what the values would be if this had not been autocorrelated. This is what the values would be. So, for example, let's go down and find one that was. Woody species, very few plants, unfortunately, they were autocorrelated. Here's one, stream bank stability. All of our adjacent samples on both banks, and even every other and every third sample, they were all autocorrelated. But we had adjacent samples on the left bank that were not, and that's the one that was selected. But if you had, and we came out with a stream bank stability value of 29, very low stream bank stability. How does it compare to all samples adjacent? Well, that was 39. So it's a little bit lower. And the confidence interval is much higher. It's only 10% on all samples, but it's 14%, 15% down here for just the left bank. So, but you can see that most of the time we're able to get, most of them are not autocorrelated. Stubble heights, none of them were spatially autocorrelated. GGW is one that tends to be autocorrelated. And of course, we only use the left bank. That's where the only thing we collected samples on was the left bank. But we found that adjacent samples were autocorrelated. But every other sample was not. So that's what's chosen in here for the value that then ends up on the data summary table. You'll see that's what's here in the data summary table. Okay, one new feature of the data analysis module is the new stubble height tab, STHT. This stubble height tab is pretty cool. What it does is it gives the key species their relative numbers in the sample and how much they were grazed. Well, you can see that easily cane is a key species. We would want that in our cane 2. We'd want that in our sample. 38 samples. And here it will give you with the combined mean stubble height, 95% confidence interval, just for cane. Now, is there any other plant that we're interested in? We have 3 pulpers, and they are palatable. And so maybe we are interested in pulper as well. So that'll add a couple more samples. We definitely don't want jewif. And the rest, there's only one. So I'm just going to look at what happens with just cane and pulper. Now, if we do that, we put those in. Now, for just those, we can bootstrap those, and that produces the bootstrapped analysis here. And notice that our sample was skewed. Our sample did not have a symmetrical distribution. It was skewed. You can tell that by going to the short-term data distribution graph and look at the stubble height graph. Obviously, there were some outliers out here to the right. And so the skewness coefficient is 2.41. We want that coefficient to be less than 0.5 to be a normal distribution. So the bootstrap normalized it. Also, for these 2 plants, now we can run a spatial autocorrelation on the stubble height for just those 2 by themselves. That's the beauty of using the stubble height tab. Okay, so here we are in the stubble height tab, and here are the results. And again, it comes back to, we end up with it'll present it right here, a sample of 41 with the confidence interval and the stubble height. It was not spatially autocorrelated. Okay, so we've got that, and we save final, and we've got that in our file now. Now we've got to deal with the photos. Remember, we have an images folder. We need to upload those. First one I'm going to upload is the satellite image here in the header form. And what we do here then is we insert. Now notice that it's grayed out up here. It's not allowing me to insert a photo. Just right click on the header tab and unprotect the sheet. I'll open that up to let you insert a picture. So we're coming from this device, the desktop exercise images. Here we go. We're going to bring the satellite image over and stick it in right here. Okay. Now we want photos, right? So we do the same thing. We're going to insert pictures from this device, and so lower across. I'm going to go ahead and select them all and just bring them all in. Now I want to do a comparison. There's a really interesting photo right here. This is the 20. I'm going to bring this copy of this one down. What I'm going to do is, see that willow in there? I'm going to crop down and highlight that willow right there, because one thing we noticed is this year this willow had died. So here in the 2011 module, we have that willow right here, and you'll notice that it was alive. So I'm going to copy the photo from there and bring that over into our module right here, and we'll also crop to that willow there. So there we have 2011 live willow plant. 2024, same willow, dead. Things have changed a bit between 2011 and 2024. One thing is the willows seem to be going out. That's one thing we've observed. Okay, so with the photos now in saved, we're done with the data analysis module, Indian Jack 2024. Before we get into analyzing trends in the statistical analysis module, I want to draw your attention to one other fact. In both 2011 and 2021, we had the opportunity, using the 2025 version, the latest version of the data analysis module, to look at our stubble height analysis and use the same key species that we used in the 2024. You'll recall that in the most recent version that we just edited, we used Cane2 and Poper. And when I go into the 21 data, you'll notice that Cane2, there were 51 of those, and the Poper there were 32. So these are definitely two good key species. But in order to compare our different data sets from year to year, it'd be good, I think, to have the same key species in here. And the results then that we're presenting here and that we're comparing are based on those two species. Now that we've got our files updated to the data analysis module, and we're currently in the 2025 version of the module for all 3 years, our last thing in the exercise is to go into the statistical analysis module and upload those 3 years into there and look at the trends on some of our indicators. So we're going to open the statistical module here. Here we are. And we're going to go to the first DMA, which is 2011. We'll open up the 2011 data analysis module, bring that into the statistics module. Okay, and filter the data. Here we go. Next thing we'll do is bring in the second DMA. That will be the 2021 data analysis module. So second one, 10 years later, 11 years later, I guess. And we filter those data for 2021. Then we move over to the right here, and we'll bring in our third DMA, which is the 2024. All right, filter those data for the third DMA. Now we've got our 3 DMAs uploaded. Now we can go over to the Comp tab and compare them. So we have Indian Jack Meadow 2011, 2021, 2024. Notice that we went to them at the same time of year. Fortunately, that was a good thing. We hit it at 6:30, 6:23, 6:26. As I understand it, the cows come on about mid-June, early to mid-June. And so we've had some grazing in all these years. And so that's why we have a stream bank coloration shown in all 3 years. Notice the stream bank coloration is a lot higher here in 2024. And our stubble heights are much shorter. Okay, so the short-term indicators are showing that woody species use, maybe a little bit more use, though we don't have a lot of samples. All right, in 2024. Stream bank cover and stability, they were low back in 11, they went up in 21, and they dropped back down again in 24, reflecting perhaps this increase in stream bank coloration. I don't know if there were more livestock on this meadow that year, but anyway, heavier use reflecting in those conditions. Interestingly, the vegetation indicators didn't change much through the 3 years. Our ecological status actually went up a little bit. Our site wetland rating did the same. Our stability rating, the vegetation rating also went up. But those changes were not really great. They're not real significant. Biomass reflects the change in stubble height, so it's why it's dropping. Did we see anything change in woody composition? If anything, it's not any different as far as how much woody is there. Woody age class, we just did not have seedlings in any of the 3 years, but we didn't have any young in this last year. Evidence that the willows, the willows may be going out of this system. And as evidenced by the one that was dead, and now we have no youngs in the sample. And other metrics, woody composition by plot, again reflecting pretty low. Woody composition hydric, also same thing. So anyway, that's the vegetation. Some of the physical characteristics are also reflecting change that's a result of disturbance. So notice that percent fines goes from 9 to 28 to 42, quite an increase in the fines on the substrate, and a very significant decrease in the size of the substrate, the average particle or the median particle size. Pools, number of pools dropped dramatically. And the residual depth is declining. Back in 2011, we didn't have the pool indicator, so that wasn't available. That's why it's blanked out there. The width of the stream, the green line width, my goodness, it dramatically increased in 2024. Again, reflecting all that heavy disturbance along the stream bank. And certainly a decline in the shade index. I think some of the willows going out is reflecting that, and the lower stubble heights. Okay, so your last assignment here is to use the data in here to generate graphs. And just since it's right here, let's just look what happened to the green line width. We got we'll copy that, the title and the data, and you stick them right here. Make sure to copy the value, paste the values in right there. You'll get this kind of a thing right here, and that's just reflecting that it's got a date format. It needs to have a number format. Okay, now this CI right here comes from the table right above. Green line to green line width. Those are the confidence intervals that were provided from the uploads. Okay, now the way you generate the graph is you highlight the values in blue. Okay, then we're going to insert bar chart, the 2D bar chart here. Bring it over here to the right. There's our, for those 3 years. Now we're going to put the error bars in here. So if we double click, if we just click and highlight these error bars, then we're going to add a chart element, error bars, more error bars. All right, and when we do that, we come down, hit the custom button, just touch that little cell there. The positive error values are right here. The negative error values are right here. And OK. Now our error bars are highlighted. So we're going to now make them more visible by increasing their width and changing that to red so that it stands out. Okay, you can see that these error bars in the back in the first 2 samples are overlapping, and there's really no difference in the green line width. But my goodness, there's a very significant difference. This is definitely not overlapping, and so graphically we can just see that here. I'm going to, here are the instructions, by the way. What I did is described right there. And I've created this for quite a few of the metrics, and I'm going to show you that from a file that I've already completed. Okay, here's the file that I've already completed. MIM Statistical Analysis Module, Indian Jack Meadow, 2011 to 2024. We'll open that up. And we're in the Comp tab. So we'll go on down and check out what we have. For stubble height, we had a significant decrease in 2024. And the other short-term indicator of interest was stream bank alteration, which went up significantly in 2024. So we definitely were reflecting a higher level of livestock use in 2024 compared to the other 2 years that we analyzed, for which we analyzed data. Then the long-term indicators are right here. Stream bank stability, and you'll notice that for stream bank stability, 24 were pretty much the same as 2011. There was a recovery back in 21. It had actually improved some, but it's gone back down in 2024. For green line to green line width, we have a much wider green line to green line width, as we did mention before, and here's the graph. For percent fines, we also see that difference is significant based on the fact that the error bars do not overlap, and it's been increasing significantly every sample. For residual depth of the pools, and these are the quality pools, the pools greater than 0.06 meter depth, we had a decline in pool depth, and there's still a little bit of overlap between the confidence intervals. These may be significantly different. we don't know. It's possible if we wanted to test this, we could put it through a t-test and find that it is significantly different based on that test. But based on this one, it's marginally different. It's potentially significantly different. But the pool frequency definitely declines significantly, although we don't have a confidence interval for pool frequencies. One way you can graphically display the Woody age class changes through time is to create a table similar to the others, only in this case we're putting 3 different columns, one for seedlings, a column for percent young, and a column for percent mature, 2011, 21, and 24. Basically, all you do here is you highlight this part of the table right there, and then insert a bar graph right there. And you'll notice that the bar graph, I like to spruce it up a little bit, the bar graph will have down at the bottom here, the colors will be displayed as to their year, blue being 2011, red being 2021, and green 2024. Notice that there were no seedlings at all in any year in percent young, only in the 2 years, 2011 and 2021. 100% of the woody plants in 2024 were mature plants. You can put a title like this, and there you have it. Now another thing you can do is look at relationships. So for example, let's suppose that we want to look at the relationship between stream bank alteration and stream bank stability. As alteration increases, it appears that stream bank stability decreases. So if we highlight and copy that block of cells down here somewhere in our spreadsheet, and I've placed them right here, then what we can do is we can highlight that section right there and insert a scatter plot. Okay, we'll bring that scatter plot over here. And then I've made a little table here to see what the relationship between the stream bank alteration and stream bank stability is. First of all, we need to find out what that relationship is. Highlighting the data, right-click on the data there and add a trend line. When we get to the trend line chart here, select logarithmic in this case because it looks like this is a curvilinear relationship. See how the dots on there curve up? It's at least logarithmic. It might even be polynomial. Scroll down a bit and make sure we display the equation on the chart and the R-square value. That's the regression coefficient. So here we have our equation. Our regression coefficient 0.75 is not a bad regression. A pretty good relationship. I like to kind of highlight this equation and the R-square a little better by blowing it up and bolding the letters. Then what we'll do is this equation right here is using the natural logarithm of x being the stream bank alteration, the x scale, and the y is the bank stability. It's predicting the stream bank stability from the stream bank alteration. So here's our alteration here in this column. Right in this cell, I'm going to put the equation equals, and we've got a minus 0.39 1 times the natural logarithm ln parentheses an x, just highlight the other column here, that's the x value, close the parentheses. Now this first equation, this first part of the equation we'll put, we'll block that in with its own, and then we're subtracting 0.057. That is the equation. Okay, so that 10% predicted 84%. If we look on the graph at 10%, yeah, it's coming up here somewhere up to 84%. Now, if we just copy this down all the way, we'll see that at 15, well, 20 here, we should be somewhere around 50. Yeah, we are 57% stream bank stability. So you see that now, using the relationship from the line graph, this is a regression relationship, we are predicting what our stream bank stability would be from various levels of stream bank alteration. If our stream bank stability goal is somewhere between 70 and 80% at this site, then obviously we want to have no more than 15% stream bank alteration. Now remember that we want to also take into account our confidence interval, and for stream bank stability the confidence interval is about 0.15. Okay, and for stream bank alteration, it's a little bit less than that, maybe 5 to 10%. So, given that, I think we're pretty safe in saying that 15% alteration would get us somewhere between 60 and 80%, and be about the middle. So this would be the goal for stream bank alteration. We were trying to not exceed 15% based on the regression. Now we can do the same thing for stubble height, and when we put the graphic together and the regression equation, we get a very high R-square value. It's almost a perfect fit in this relationship between stream bank alteration and stubble height. Interestingly, then we can come over to the same percent alteration, 15%, that we use to estimate the level for stream bank stability, and our stubble height is just over 7 inches. So I think a 7-inch stubble height standard might be a good one based on this kind of analysis. Also, one other thing, as I mentioned before, we didn't have a lot of change through the years in our vegetation ratings. Primarily, the change that we were really interested in was the fact that the woody species age class had changed over time, and so that we only had all mature plants in 2024, whereas in previous years we did have some young plants. We can help strengthen that argument by looking at our species composition. So I do have a species composition chart, and this is just using the plant species code and green line composition that comes from the data analysis module and the graphs tab. So back in 2011, here's our composition, and I just sort them from largest to smallest, and do the same for 2021 and 2024. This is actually Indian Jack 2024, this one here. And notice that Nebraska sedge is our dominant species, and it increased through time, which is really interesting, showing perhaps why we see a little bit higher level of hydric plant composition in this most recent sample. Also, we can see though that our woodies decline, and a good way to do that is to put these plants together in their functional group. So with sedges and rushes, we see that they increased mainly because of the increase in Nebraska sedge. The grasses stayed about the same as pretty much through time. Forbs went up and down, kind of back to about what it was in 2011 and 2024, but woody plants certainly did decline. So the functional groups help us to validate the fact that we had a decline in woody plant composition, and that was the main influence on the vegetation composition through the years at Indian Jack Meadow.